Hello, and thank you for joining me for the fifth data analysis bootcamp class. We're going to go through the Python workbook, and well, let's get started. So here, downloading some different libraries to get us started here: Pandas, Seaborn, Matplotlib, and NumPy are standard kind of data science libraries. The dataset will be included at the end of the class. If you want to download the actual dataset and upload it from your Google Drive, this is the code that you would use. If not, the dataset's available in my GitHub reservoir and you'll be able to download it directly from there. Okay. Let's get started working on this. Okay. So if you've been noticing, I don't like the standard colors and using them. I get kind of bored of those default colors. They're nice, you just kind of get bored of them. I like to make color palettes in here, so I'm making a color palette right here of some set colors, and we'll just play around just to make it a little bit different as we go through our class today. So getting started, I think this is always important, even in a bivariate relationship, it's really important to understand our variables a little bit. Okay, so here what we're going to do is for feature in df columns, do a figure size of 6,3, so 6 by 3, width by height. We're going to do data type equals to an object, SNS count plot if it's an object, and choosing a palette color right here, and then x ticks rotation 60. Else, I'm going to do a hist plot and do a numerical value, and this is only going to use one palette color, so I'm just going to do palette equals 0 and use the first color for my palette. Going to add a title regardless, and then show the plots. This doesn't all just happen on top of each other. Okay. So I think it's always really important to highlight so we can save time later on in our data analysis. Even when I'm doing one for myself, I always write down these little notes. I saw this, there's an imbalance here. Especially as you really start pre-processing your data, you start getting further into your data analysis, it's fine to come up back to the plot, but it does take a few extra seconds versus just looking at your notes. So it does really speed things up just writing a short little note for you. And then if you ever have to show this to anybody, your notes are already done for what you're seeing, okay? So it's just a good idea. Again, it does seem a little bit, I don't want to do this just for myself, but it will end up saving you a lot of time. Okay. So getting into some different plots that we can do in our bivariate analysis. And we'll go a lot more into detail in this in future classes, but just giving a highlight right now of the heat map. So this shows really the correlation matrix that we talked a lot about, and really highlighting when it's negative and positive. It is kind of, unfortunate the way it works is that you can't really get a good sense of this one is stronger, but which is actually, the stronger negative, and where's the strongest? Is it right here? Is that the strongest positive, or right here? So I think a really good idea to do this is you note equals true, puts the numbers in there. It can be helpful. You see it's a little bit squishy though, right? So I actually like to make this a little bit bigger first, put a figure, blt.figure, fig size 8 by 6, and then I'm gonna put my correlation matrix into that, and we can start to see we get a little bit nicer plot here. Okay. Looking at correlation, making this look a little bit nicer. I don't like the standard color in Seaborn. Maybe you do. Not my cup of tea, I guess. The lava color is kind of, yeah, I don't know, it's not my thing. So I usually use crest equals, see if I feel like doing it really quick, I use the preset crest. I'm gonna add a title here, and just notice here that I'm doing a line break before and a line break after. This is to add a little bit of space before and after the title, so it's not so crunched up, just crushed right into the top there. I think it makes it look a little bit nicer. Font size 16, font weight bold, font weight is how you change the style, and so bold. And then plt.tight layout is just going to make sure everything is sitting nice, because I did I did some more formatting to this heat map. It's just a good idea, although I didn't do very much. It is still helpful just to kind of reorganize everything. It's not going to make everything tighter. It's just going to make sure the spacing is correct on everything. So we can do that. I often like to play with this diverging palette though. Okay, so the way diverging palette works, let me just run this first. It allows us to select two different, a high and a low value. So this is fine when we have positive and negative. Crest works well. We can already see the high and positive ones, but if we want to have custom colors, diverging palette is very handy. Okay, so we're going to do this, and this allows us, it's very hard to know because you just need to choose two numbers. It's from 0 to 360. If you don't know what those numbers look like, it's pretty hard to choose. So this choose diverging palette is a good little function that lets you go through and choose the different colors between these two. So what this is high negative or negative color, positive color, the separations. This is between how much kind of white space is between the two, distance between the two colors. Light is, or sorry, saturation, I apologize. S is for saturation. So if you go down to 24, gonna basically turn off the saturation. If you go all the way to 2599, it's gonna make quite colorful, I guess. So it really depends on what you want to add. And it's going to once again to restart this. And then looking at L, that is how light our palette is going to be. And I'm going to do what colors we want to get rid of. S or sep is going to be the separation. So it's the distance between the two outside colors, right? So really just adding more white space into the middle, how many colors we wanted this to be, and if we wanted it to be dark center or light center. I don't know if light center ever really works, but maybe it will for your situation. Okay, so playing around with that, I just settled on 22. I honestly find almost any of these two colors work together, but 22 and 20, I have to just choose two random ones and see what it looks like. And it looks quite nice. Right here, we got a very customized, very unique correlation matrix that truthfully would be hard to do otherwise. And now we can really highlight what is the strength of a relationship, but also very much highlight which is stronger, which is weaker, and really understand which is the highest strength in our relationship. Here we're very isolating. The foot length between the ear conch in our possum data set seems to have the highest correlation. Okay, so we're learning a little bit of stuff about our data set. The skull width as well has a very strong relationship with handle width. And the site, though, and the case number, that probably relationship is a little bit skeptical because that's just where they were sampled from. And so they probably do have a correlation, but it's not something that we really need to understand in our data set. Okay, just going over the classic scatter plot. We don't really use this too much in sense. There's not really a lot that we can do with this in a sense. So what we often do is we use the reg plot. Okay, so what I'm going to do here is just to make sure none of the data was sitting on top of each other, because sometimes you would see it is sitting right on top of each other. We go jitter true y, jitter true x is going to move those a little bit, so it's kind of a little bit more spread out, and we get a better sense of how much data there actually is. What I'm also doing here is I'm doing scatter KWS color. So what this is going to say is this is really good practice with Panda or Python, doing some more advanced things with our plotting functions. It's really cool that we get to play around with this and just see, do some more advanced Python, but really see the results right away. Okay, so this is we're passing a dictionary to my function that's going to control a lower level function. So regplot is actually made up of a scatter plot and a line plot. Really good practice is passing a dictionary to the function to control a lower level function. It's going to pass this to line KWS or pass this one to scatter, the scatter plot, and change the color of the scatters, the dots, and then this is going to change the color of the line to make up the line plot. And then here, just looking at a different variation, we're noticing here in this one, seems to be like there's two clusters in this one. So we can go through this and explore this a little bit better. Here, I did a pair plot, and now what a pair plot is really good is really busy, if you could say that. It's almost too much to really get into detail with. The reason that we don't generally go into super detail with this one, we look at this as a starting point because there's lots of bivariate relationships. Which ones are important? Kind of hard to know when you get started. And so it's good to kind of go through this and use our eyes to start detecting patterns. You can see high correlations here. Let's see a little bit of a clustering going on in this data set in this column with ear conch. So maybe we can use that as well over here, ear conch. It's very interesting a little bit over here as well. Seems to be a negative relationship, positive relationship, and kind of highlighting what would be more interesting, chest and what's this one? So chest and jumping around there. Chest and belly have a seemingly like a pretty positive correlation, which would make sense, right? So we want to expect that. It looks like a pretty solid correlation there, but this gives us a better sense of our data than just it. I feel it's a good supplement to the correlation matrix, so we can visually inspect it quickly. This is not what you're going to present in your report, though. You're going to use this to figure out what you want to look at in a little bit more detail. Pair plot is great. I like the ParGrid because there's just a lot of cool things that we can do with the ParGrid. So same idea here. What we're going to do is we're going to do a ParGrid and go assign it to G. I'm going to put in my columns right here. I'm just going to select column number, the third column, basically my numeric columns in this data set. Hue equals sex, and so I'm going to change the color by the hue. I'm going to map, on G, I'm going to go map underscore diag and put a KDE plot on the diagonal. I'm going to put a reg plot in the upper right. I'm going to put a his plot in the lower left. Okay, and here, notice this, what I'm doing is if I want to pass something to reg plot, because map upper is actually taking control of the reg plot, I'm referencing my function. Notice that there's no parentheses right here. I'm referencing reg plot because map upper is going to take control of that. And so I need to pass, if anything I want to pass to reg plot, I'm not going to put inside those parentheses. I'm going to give it to map upper, and it's going to pass that to reg plot for. Okay, a really cool thing that I like to do with this grid plot is we can, do a swarm in the middle. I think the most important thing is doing a residual plot with a reg plot. So we can do the correlation here. We can also do the residuals of the correlation, right? We can start to see and understand if our patterns in our residuals, we have to wonder if, what's really going on with that relationship. It can be a little bit deceiving and to understand what's really going on if we don't see these errors in our analysis and really get a truer sense of what's happening in our data sets. Okay, so it's kind of interesting. You see actually, so we have very low errors, and there doesn't seem to instantly be any patterns. We're seeing some clusters over here when we see by the population. We're seeing the population seems to cluster or make a little bit more errors on the lower side versus the higher side in the total length. So maybe population has something to do with the total length of an ad. Okay, it'd be interesting to explore a little bit more. Okay, line plot here, going through this. This is a really cool, LMplot is a really cool, powerful tool to do linear model plot and really look at those linear relationships. The cool thing about this is I can do X and Y, but now also we use the row argument to then segment this a little bit further. Okay, we're seeing here these two clusters seem to be pretty consistent between these two variables. A little bit stronger in the female category. Interesting. Okay, so what I'm going to do next here, I wanted to continue to explore this relationship. I need a couple more categories to be able to filter this by either rows or columns by the category and do an individual linear model and individual regression for each of these. Okay. So what I'm going to do that is I'm going to do pd.cut, cut this variable. I'm going to bin it, essentially go from the lowest just outside of the edge, go up to 4, and then from 4 to 10, just go on the outside to make sure I capture every data point. Send those to young and old just to keep it as simple as possible. Create 2 categories from the age bin. And what starts to get interesting is you're seeing by young, the clusters seem to be stronger between ear, conch, and tail. Still there in the older ones, but less strong, I would say. So let's make another category. And when I looked at this distribution, one of the first things that we did was plot the distributions. And so here what I'm kind of seeing is, it looks like there's almost a bimodal in this relationship. And kind of interesting. So maybe what I'll do is I'll do feet low and foot length low, foot length high. Again, just binning this into 2 categories. These are my outside edges, and these are going to be the names of my labels. 2. And as we see, really interesting here. So I now did the ear conch by tail, foot length bin. Actually turn down the height just so that we can see this in the video. You actually see it's a really amazing. We get the amount of that we're able to separate this now by those 2. It really seems distinctly quite a bit. Let's see if we can go a little bit more and do the same thing here. What we're going to do now is setting the column by the age bin. So we're going to do the foot bin as the hue and the age bin. So it's really interesting now. We're almost able to completely, on this side, completely separate this group over here to the side, almost on the right side here. So it's really interesting that the ear conch and tail are very highly rated to the age, or very much related to the age, but also the foot length. Very interesting. So something in this cluster, we could start defining it by the ear conch, the tail, the foot length being higher on the higher side. And so we're starting to understand what makes possums tick, kind of understanding this. It's not really the population. It's not really, where they came from. really related to maybe how possums age. I'm not a possum expert, but this would be the time that I would want to talk to a domain theory specialist who really understands those possums and can give me a little bit of insights into why am I seeing this, right? Because there's absolutely a reason. We just need to understand now why. Okay, that's the one thing that data can't tell you is the why. So thank you so much for joining me for this 5th data analysis bootcamp class, and I will see you in class number 6. See you there.